Hi Joe, welcome to my channel. With me, I'm your mystery teacher, and today we're going to study a new and a very important topic, especially for class 9th and students upwards, and the topic is inertia and Newton's first law of motion. Here we are going to study what is inertia, what are the different types of inertia, what are the different factors that affect inertia, as well as various examples. Okay, so let's quickly dig in. Now, what is inertia? Inertia is nothing but the tendency of any body with mass to resist its change in state. Okay, it's not a force, please remember. It's not a force, it's only a tendency of the body. The body has the capability to resist its change in state. State as in state of rest, state of motion, or the state of direction. So if a body is at rest, the body will have the tendency to continue being at rest, and that is called inertia of the body. Or if the body is moving with a uniform speed, then the body will continue to move with a uniform speed, and that would be called the inertia of that body, right? And direction also is something that we'll quickly discuss in some time. So essentially, inertia, we can say, is nothing but resistance to change in rest, motion, or direction of a body. Now, something very important to understand here is any body that has mass, any mass, even if it's very minute or feather-like, even then that body will have inertia. Okay, so every body or any body that has some amount of mass exhibits inertia. Fine. Moving on, let's understand inertia with a few examples. Now suppose, I'm sure you must have seen that when you're traveling in a bus or when you're traveling in a car for that matter, suddenly when the car accelerates, you tend to fall forward, right? Suddenly when the car is applied brakes, you tend to fall forward in that scenario. And why does that happen? Think about it. We just discussed inertia is the resistance of body to change in its state. When you're traveling in a bus, the bus is in motion and so are you. The bus is moving in this direction and you are sitting inside the bus, so you're also moving in this direction, right? Suddenly if the bus applies brake, the bus has come to rest, but your body has the tendency to continue moving in motion, right? So what happens, because your feet is touching the bus, your feet comes to rest, but the upper part of the body is still continuing in motion, and that is the reason you tend to fall forward. You see, right? The reason is your original state of the passenger is in motion. But because the external force is applied, which is brakes applied by the bus driver, your feet comes to rest, but your upper body is still in motion and it falls forward, right? Now, second example is when you beat a dusty carpet, the dust comes out, right? Why does this happen? Now, again, same logic, the dust on the carpet is at rest. The original state of the dust is at rest. When you're beating the carpet comes to motion, you're applying force on the carpet and the carpet is coming to motion, but the dust continues to remain at rest. So dust remain wherever it was situated. The carpet moves back when you're beating the carpet, the dust remains there and the dust gets removed from the carpet, right? Again, this is an example of inertia of the dust in this scenario. Okay, inertia exhibited by the dust is the reason why the dust is removed from the carpet upon beating the carpet. The third example is, and it's a very common example when you study inertia, is when you flick the card, the coins placed on the card fall into the glass. This is a glass that you've taken, you fill it with water, you put a card on top of it and you put some coins. When you quickly flick the card, the coins are not going to go away with the card and the coins are not going to go flying over. The coins, they're placed here, you remove the card, they're going to fall down into the glass, right? Why? Because the coins were initially at rest, you applied force to the card, but the coins continued to stay at rest, so the coin is going to fall down. It had a base, so it was settled on the card. When you removed the base, it's going to fall down, right? So coins exhibited inertia. What was the initial state of the coins? Rest. You removed the card, the coins continued to stay at rest, and that's why the coin falls down into the glass. Correct? The next example, again a very common example from our day-to-day life. When you shake a tree, you see this tree is giving out dollars, but I hope that's the case in true life also, in real life also, but trees give us a lot of wealth, but not exactly currency, right? Anyway, coming back to the point, when trees give you, when you shake the trees rigorously, what happens? The dry leaves or the ripe fruits, they fall onto the ground. Why does that happen? Again, think logically. When you're shaking the tree, you are applying force on the trunk and the branches of the tree. So the branches and the trunk come in the motion. Branches of the tree come into motion. But the leaves of the tree, they remain at rest. Leaves continue to remain at rest. And that is the reason when this is moving, the leaves would exhibit inertia and not change its original position, and that's how they tend to get detached from the tree. Again, an example of inertia. Okay? Now, let's understand the characteristics of inertia. We have discussed inertia again. It is a tendency of the body to resist any change in its state of motion or state of rest or state of direction, something that we're going to take it in this video in a few minutes. Now, very, very, very important thing, inertia and mass. I told you every object that has mass will have inertia. And inertia is directly proportional to mass. What does that mean? That means you have, let's assume this is an elephant. You have an elephant here of 500 kgs. Okay? And right next to it, you have a tennis ball of say 2 kgs. Both are lying on the ground. Both are at rest, both of them have mass, so both of them have inertia. So if they are at rest, both of them will continue to be at rest like we discussed, right? But tell me, if you are standing here and you want to apply the same amount of force to push this elephant to bring it into motion and to push this ball to bring it into motion, for which of these will you require more force? Think and tell me. Clearly, it is the tennis ball that you would require lesser force, not more, right? So for the tennis ball, you can push it very easily and then it will come into motion, right? For elephant, you would really have to, alone you'll probably not be able to move the elephant also. You would probably need a trunk or a bigger JCB or something to move this elephant, correct? So that means that elephant which had higher mass offered higher resistance to change in its motion. Can I say greater mass meant greater inertia, right? Elephant offered greater inertia to change its state, and the tennis ball offered lesser inertia, right? You could move it easily. Correct? So that's what mass is, directly proportional to inertia. Always remember. And the second thing, please also always remember, inertia is not a force. It's not a force that is acting on any body. What is force? Force is nothing but a push or pull that you apply to any body, right? But to understand it simply, but inertia is merely a tendency of a body. It's the tendency. Body will exhibit this tendency that whenever it's at rest, it will continue to be at rest. Whenever it is in motion, it will continue to be in motion. And a very simple example of that is, say for example, right now you probably have your book or your laptops or your tablets on a table, and it's an object which has mass. Of course it will have inertia, right? So right now if it is at rest, the book will continue to be at rest unless you move it, unless you apply external force and move it, right? So that is inertia of rest, correct? Now coming to the different types of inertia. there are three main types of inertia: inertia of rest, inertia of motion, and inertia of direction. Inertia of rest says that a body will continue to be at rest, okay, if the original position of it was at rest, right? For example, see, this lady is standing in a metro, and as the metro accelerates, when the metro was stopped, the woman was also standing and she was at rest. But as the metro accelerates, metro is in motion, her feet is attached to the metro, so the feet comes into motion, but the rest of the body is exhibiting resistance to change because the rest of the body is still at rest. And that's why what happens, the lady tends to fall backwards, and that is called inertia of rest. That a body, when it is at rest, will continue to be at rest unless something externally applies a force on it and tries to change its state of motion. Clear? What is inertia of motion? Again, that if a body is moving in a uniform motion, or if it is in a motion, right, it will continue to be in the motion unless an external force is applied on it. Right? The best example of this is a pendulum. If you put a pendulum in vacuum when there is no air friction, and then you bring it to one side and you leave it, the pendulum will keep going on and on this way till eternity. It will never come to stop, right? That is inertia of motion, that once it is in motion, unless you apply external force, it will continue to be in motion. Another good example is, look at this video. When an athlete is trying to take a long jump, it takes a run up and then come, see, till here your body was in motion. At this point, the body has stopped being in motion because there is a jump. But even though the body has stopped being in motion, because the tendency of the body was to continue being in motion, what happens when the athlete stops jumping here, it doesn't fall down here. It goes a little forward and then comes to ground, hits the ground at this position, right? Again, inertia of motion. And the last and the very important is the third type of inertia, which is inertia of direction, which says if you're moving in a particular direction, your body will continue to move in that direction unless an external force is applied on it. Suppose you're moving in a car and you're moving straight. Now, if the car suddenly takes a turn to right, what's going to happen is, because your body was moving straight and the car took a right turn, so the car has moved here, the car has moved here, your body will continue to move straight, and from inside the car it would look like your body has shifted or your body is tilted towards left while you're taking a turn. Why does that happen? Because of inertia of direction. I hope you understood clearly the different types of inertia, how is inertia related to mass, and what exactly inertia is. Okay, thank you very much, Bacho. In the next class, we'll take up the law of inertia, or the Newton's first law of motion.